Hello everyone, Mr. MathWell here. Just going to do a quick Patels rule problem, and this is one from a practice exam here, practice AP exam. And when you look at something like this, a question like this, a limit tan of x minus 3 over 3 times e to the x minus 3 minus x, that looks really ugly, like super, super ugly. What you want to do with any limit problem, right, is you want to plug the value in here, the a value, which is 3, you want to plug that into the function just to see if you actually have a value. Because if this is continuous, if this 3 here is not a restricted value, then you may have the actual value of the limit by just plugging the number in. We can see though, and we'll quickly see here that we have a bit of an issue. First of all, you want to check the denominator. 3 to the times e to the 3 minus 3 minus 3. Well, this is going to be e to the 0, which is 1. 3 minus 3, that does equal 0. So we do have a restricted value. What we want to do is we want to check the top, though, as well, and see what happens if we plug 3 in here. Well, tan of 0, if you remember on your unit circle, 0 degrees has a coordinate of 1, 0, and tan, of course, is sine divided by cos. So tan is 0 divided by 1. So that's equal to 0 as well. So we have 0 over 0, which is an indeterminate form. That means that what we can do is we can use L'Hopital's rule. So you want to quickly check that, right? With any limit, throw the number in first in the denominator, see if you have a restricted value. And if you do, then check the top and see if it's 0 over 0, because if it's 0 over 0, you can use L'Hopital's rule. So what we'll do is we will take the derivative here of the top, which I believe is secant squared and of x minus 3. And of course, chain rule says we multiply that by the derivative of the inside, which is just 1. And the derivative here of the bottom, let's see, this is going to be 3 times e to the x minus 3, and then times the derivative of what the exponent is, which is just 1, and then that's minus 1. So if we have that as a derivative and we plug that in and plug 3 into there, so what do we have? We have secant squared of 3 minus 3, and then over here we now have e to the 0, which is 1. That's 3 minus 1 is 2. So I'm just going to zip down here to the solution. So what's nice about these practice exams is that they have sort of the topic here. So this is L'Hopital's rule, and it's indeterminate form of 0 over 0. And so they go ahead and oh, whoops, I think I might have got that wrong there. Anyways, so they have the oh, sorry, that's the incorrect one I was looking at. So yeah, here we go. So they have the solution here, and I guess the nice thing is too, like my eyes just kind of gravitated to be there for some reason, but they kind of show you why the solutions are incorrect, what common mistake might be made. So C is correct. The limit is 1/2, and I guess if I go back there, I don't know if I can find it now. But if I go back to that question, oh yeah, there it is. So then, we have 1. I think we said that was 1 over 2. And when you evaluate that, you get your half, and so there's your answer. Okay. So the thing you want to remember is if you have an indeterminate form of 0 over 0 or infinity over infinity, when you just plug your a value in there, then you can use L'Hopital's rule, which is simply taking the derivative of the top and the derivative of the bottom, then throw your number in and see if you get an answer. If it doesn't happen, then you can keep taking the derivative and see if you are able to get a value. Okay, so there's a quick example of L'Hopital's rule. That is straight from the AP practice exam, so good luck with that.